Hello everyone. Let's discuss something about a new topic or already existing topic, but we'll discuss in a new way, right? So let us discuss what is resistance, right? So in this lecture, we are going to discuss what is resistance in a different way, in a altogether different way, right? Now, I am also going to write what are the topics to be covered, right? First, I will be discussing what is resistance, and second thing is laws of resistance, and third thing is Ohm's law, right? These are some of the important topics, right? Now we are going to see everything in a different way and in a short manner as possible, right? Let me change my color. Fine. Now, what is a resistance? A resistance. A resistance, generally what we call for a human body, what we call resistance, right? Anything which is opposing is called resistance, right, we are resisting ourselves, right? We will be calling in English like we will be resisting from others, etc., etc. We will be right, we will be like some quarrel is happening and some person is hitting us, so we will be defending or we will be resisting ourselves, right? In same way we can write that resistance is defined as opposition, right, offered to the flow of electric current, right? So generally, let me write in a conductor. Hmm, right. Generally, let me take this as a conductor. And whenever we give a voltage source, current starts flowing, right? Current will be flowing from here, from the positive terminal to negative terminal, right? We generally know this. Now, what we say that current is flowing, through which current is flowing, I mean what are the base element through which current is flowing, we can say electron is the key contributor for current flow, right? So we can say electron is a key contributor for current flow. Therefore whenever this electron is coming in this way, right, in this way, and this conductor will have certain molecules, right? Every conductor or everything in the universe is made of molecules, right? So it will be having certain molecules. Whenever these electrons come closer, these molecules will start opposing and both gets collided, right? Both gets collided. Here these molecules, right, these are opposing to the flow of electric current or opposing the flow of electrons through them, right? So in this way we can define resistance as opposition offered to the flow of electric current or flow of electrons, right? Now what is happening? Now whenever these electrons are coming here, the molecules the molecules start colliding, they are having a gate quarrel, right? After colliding, what will happen? They will just dissipate certain heat, right? So generally we will be seeing whenever two bodies come closer and they will be colliding, they will be having friction. This is nothing but electric friction. Resistance can also be defined as electric friction, right? Electric friction. Now whenever they are colliding each other, what we will be getting? We will be getting heat. So we can conclude that resistance is heat dissipating, right? Resistance is heat dissipating. Let me give you a clarity that resistance and resistor are different. Resistance is a property. Resistance is a property, whereas Resistor. Resistor is a element which is exhibiting resistance, right? Resistor is a element which is exhibiting resistance, whereas resistance is the property, right? Please don't get confused through these two, right? Now let me conclude this. Now resistor, we are calling it as a heat dissipating element or a heat dissipating property, right? So we are getting, I mean, till now we got 2 points. The first point is a resistance is the property which opposes the flow of electric current. This is first property. Second property. Second property is resistance is a heat dissipating property or heat dissipating element. Right. Now, it is generally denoted by R. Resistance is generally denoted by R, right? Now what is the unit of resistance? What is the unit of resistance? It is ohm, right? Ohm. This is the symbol of omega, right? Or ohm, right? We got a law called Ohm's law, right? This is proposed by G.S. Ohm, right? On behalf of his name, we kept the unit of resistance as ohm, right? So we got 4 points now. We got 4 points in our hands. Now let us move forward and let us see what are the laws of resistance, right? Laws of resistance. Resistance is one more important point. We forgot to mention the symbol of resistance. Symbol of resistance will be something like this, right? This is the symbol of resistance. This is the symbol of resistance, and there are many types of resistors we are going to discuss in the later classes. There are many types of resistors like various star, variac. There are many types of resistors we are going to see in next classes. Now, for time being, let us consider this as the symbol of resistance, right? Now, let me move forward to the laws of resistance. Now, what does the first law states? First law of resistance states resistance of a conductor is directly proportional to the length, right? Resistance offered by a conductor is directly proportional to the length. What does the second law state? Resistance of a conductor is inversely proportional to the area of cross section of conductor, right? If I assume this as a conductor, resistance will be proportional to the length of the conductor, right? Length of the conductor, and it is inversely proportional to the area of cross section of conductor, right? And now resistance also, this is important point, resistance also depends upon temperature, right? Resistance also depends upon temperature. It can be either directly proportional or inversely proportional. We will be seeing that in the later classes. As per time being, let us remember that temperature also depends, I mean resistance also depends upon temperature, right? So these are the three most important points, and there is one more point. Resistance also depends upon the nature of material. Through this we will be getting one more conclusion actually, right? So resistance, there are four laws of resistance. The first law states that resistance of a conductor is directly proportional to its length. First law is done. Second law, resistance of a conductor is inversely proportional to the area of cross section, right? Second law done. Third law, resistance depends upon temperature. Third law done. What is fourth law? It also depends upon nature of material. Done. 4 points done. Now let us conclude it into a single thing, right? R proportional to L divided by A, right? Are proportional to L by A, right? From 1 and 2 we got this conclusion. Now if we want to remove this proportionality constant, we need, this proportionality symbol, we need a constant, proportionality constant, that will be rho L by A. This rho is called resistivity. This rho is called resistivity, right? So R is proportional to length and inversely proportional to A. After removing the proportionality symbol, we got a constant which is rho, that is resistivity or specific resistance. Specific resistance, right? It is generally denoted by rho. Please do remember this rho, right? About rho and other terms we will see in the next class, because our main focus is on the resistance now, right? So we got laws of resistance as 4. We done all the 4 properties, 4 laws we have seen. Now the final conclusion we got is R is equal to rho L by A, right? As far as the time is concerned, this is the conclusion here we got, right? In the first slide we got 4 points as our conclusions. In the second slide we got one major conclusion and one major formula, right? Now what is the third thing? Third thing is Ohm's law, right? Ohm's law. So generally we give voltage source and current is flowing and the conductor has some resistance. Now what does Ohm's law states? Ohm's law states that at constant temperature, this is the mandatory statement, right? This is the, we have like a mandatory situation. This is the mandatory thing. This is mandatory. I am saying it 1000 times. At constant temperature, current flowing through the conductor is directly proportional to potential difference applied across the ends, right? So at a constant temperature, current flowing through the resistor or conductor, whatever it may be, is directly proportional to the potential difference across the ends, right? Current flowing through the conductor is directly proportional to the potential difference across the ends, right? For time being, let me change it to conductor only because we are not familiar with resistor till now, right? I is proportional to V. Now, if we want to remove this proportionality, we need a constant. Again, we need a constant, right? So, I will be replaced, the proportionality will be replaced by 1 by R into V, right? So, this can be simply written as I is equal to V by R. Simply, this can be written as I equal to V by R. From this, we can get millions of formula. In electrical engineering, we can see many formula. This is the fundamental formula for everything, right? I is equal to V by R. So here we can say that if resistance is high, current will be low, right? Current will be low when resistance is high because they both are maintaining inverse relationship. Also we can see from this only, we can see if resistance is high, that means here opposition is very high, opposition person is very strong and the current person is very weak. So let me take this as opposition and current person is very weak, so he will come and he will hit it, so the net current will be reduced automatically, right? If the if we let me consider this as resistance, the opposition person, this fellow is very weak. Now I am bringing a double strong current. Now what will happen? He will easily surpass, right? He will easily surpass. So we can say that current and resistance are maintaining an inverse relationship. Current and resistance are maintaining an inverse relationship, which is the base statement actually, which is the base statement, right? So we got two conclusions here, two main conclusions. The first thing is the definition. At constant temperature, current flowing through a conductor is directly proportional to the potential difference across the ends. Done. One is done. And the second is I is equal to V by R. Done. The third thing is current and resistance always maintain a inverse relationship in the circuit, right? This is called a circuit actually, right? Electrical circuit. In this circuit, they both maintain an inverse relationship, right? We got two to three conclusions here also. And main thing is this Ohm's law is proposed by G.S. Ohm. He proposed this Ohm's law. And there are many limitations regarding this Ohm's law, because this Ohm's law is valid only at constant temperature. But an intelligent student will question, what happens with the variable temperature? Right, variable temperature is there. So Ohm's law is not valid there. Also, this is valid only for linear elements. Only linear elements. It is not valid for any non-linear elements like diodes and all, which we'll be seeing in the later classes. Because I can't go through non-linear and linear as of now, right? So we have two major drawbacks. That is, variable temperature is not applicable in Ohm's law, and the second thing is it is not applicable to non-linear elements like diode, etc. Right? And there are many other disadvantages also. But for time being, let us see Ohm's law only. After that, in the later classes, we will see what is so-called things. Right? So we are done with the theory part. What is resistance is done, and what are the laws of resistance is done, and Ohm's law. What is Ohm's law is done. Now let us go through a problem. This was asked in NEET 2013. Right? He gave one thing. A wire of resistance 4 ohm is stretched to twice of its length, twice of its original length. The resistance of stretched wire would be, right? So he gave, initially the resistance was 4 ohm and the length was stretched twice, right? Initially this was the length and it was stretched twice, right? So what is the new resistance? Many of the people will have a conclusion that we know that R is equal to rho L by A and R proportional to L. Therefore, R2 by R1 is equal to L2 by L1. R2 is equal to R1 into, what is L2? L2 is twice that of the initial length, 2L1 divided by. So the answer is 8 ohm, right? Which is wrong. Which is obviously wrong. Close your eyes. Which is wrong. Right? Why? Why? Because there is one more person here. Who? Area. We have to consider that fellow also. Right? Here, the main point to be noted is volume will be constant here. Volume will be constant. In such kind of, in such kind of problems, the volume will be constant actually. He said length is doubled. That's it. There is no change in volume. So volume is constant. So in order to get the volume, we generally multiply with length, right? So rho into L square divided by volume. Now volume is constant. Also, this is constant because he didn't mention anything about that. So now we can write R is proportional to L square, right? L square. Now we got the answer. What is length 2? What is the new length? It is double the original length. Double the original length. So R2 by R1 is equal to L2 by L1 whole square. R2 is equal to R1 into 2L1 divided by L1 whole square, right? So because L2 is twice of L1, L1 will get cancelled. So R1 into 2 square, 4. What is R1 initial? 4 into 4. 16 ohm is the right answer. 16 ohm. Option B is the obvious answer for this question. Right? There is nothing to be remembered here. Is there anything to be remembered? If we know this thing, the only other thing to be considered is volume should be constant, because he didn't mention anything about volume. Also, he just mentioned length is to be doubled. Initially, the length was this much and he is doubling this, right? But the volume is constant. Volume is constant, right? That is why we got 16 ohm as our answer. Option B is obviously right, right? So I hope the lecture is very clear, and we have seen many good points, many new points about resistance and all. I hope the concept is clear. Thank you.